Hi everybody, we have a new project. Okay, this is a tracking the moon, but it's tracking the waxing and the waning of the moon. Means that you have an inclination with north and south, all right? And when it's in the north, the LED, red LED will be on. When it's on the south, on my side, it will be the green light that goes on. But it's to do with the inclination. Now, waning is when the light slowly goes away, and waxing is when the light is coming back on the moon's surface. Okay, so this is practically the way it works, and you can see here. I put a PW so that as the moon becomes darker or the light goes away in waning, the LED fades, it becomes dimmer and dimmer. And when the light is on waxing, which comes up, more light comes up by day, the LED will come up. The light will lit up more and more. And here you have the timestamp, you have the inclination, and the PW, which measure from 255 in this case. The PW is, let's see, we are on the Northern Hemisphere, the inclination is, PW is 107 at the moment. So it's less than half. Sorry. Then we have the inclination, and we have the waning. Moon is waning at the moment. PW timestamp. It's 9:25 on my side. Phase 29.2%. All right. Now let's have a look at the code. It's a bit complicated. So what it actually does, I put an explanation here because it's a Boolean. The Boolean is north, currently declination, DCL. That's why you have the declination, and it's greater than my latitude in this case. If the moon's declination is greater, then I am minus 33.92 because it's on the south, and it's north of my location. Red light, red LED, it's on, lights up. If it is less than minus 33.92, it is south of my location. Green LED lights up. Okay. Also remember, in my case, you will find that, I don't know about your case, but the declination range from roughly plus 28 degree, okay, plus 28 degree, sorry, let me make it bigger so you can see. Okay, so plus 28 degree to minus 28 degree over the lunar months, okay? Since Cape Town is quite far south, plus minus 34 degree, the moon is often north of my location, okay? So red light north, the red light, because it's always on the north, it will always be on more than the green one. It's in my location. Your one will be different, okay? So what you have to do as well is to put your location. I think I've got. Sorry, I want to do something quickly. Stay there. Okay, hold on. It's quite a lot of information here. Okay, as you can see here, you can see the say PW 107 at the moment, time 9:30, phase 29.2, and its declination minus 12.2 Northern Hemisphere. Okay, so let's go back to the code. So you got to, here you got to put your username and password. The caps. So let me just type your ID. Man. Okay, your SSID here and your password. Okay, so then we just you have the pin, the green light is on D3 of I'm using a Wemos ESP. Let me go to the to the scene. Okay, this one, it's a Wemos Mini Pro ESP8266. So you have the red LED goes on pin 4, and the green LED it's on pin 3, but you can put it anywhere you want. This is an I2C, so it's using only two wire, and it's ACL and SDA. ACL is on D1 and SDA it's on D2, pin 2 or D2. Okay, here's a railing. It's 5-volt railing and the ground, so you have a ground and a railing. And the LED, remember, on the, show you one thing. Sorry. Okay, so the cathode and the anode. Remember that the longer leg is positive, the shorter leg is negative. So you put the negative on the resistor and you ground the resistor, okay? Otherwise it will burn your LED. You ground the resistor and on the shorter pin, and then you put the D, in this case a D4, on the longer pin, which is positive. That brings electricity in and electricity out on the ground. Okay, so remember that, but I'm sure when you get to this point you should probably know that. Alright, let's go back to the card now. Where am I? Yeah. Okay, so your password and your your network's name, okay? Remember here that we need a several library. One particular is a MATS, and that is a Ticker.h, okay? So here I put my latitude, okay? But then you must look for your latitude and replace this one, okay? All the rest stay the same. The lunar cycle and the pi, 314 is a radian. Okay, the ticker PWM updater. So practically what it does is the LED become dimmer as the moon is waning, and the LED become lighter when the moon is waxing. So practically, but it's so slow that you probably don't notice. But you will see that when it goes away completely, the LED will become darker, and the green one, in this case of mine, will become lighter. Okay, so What else is here? It's this is for the obviously initialize your pin numbers for the LED, and then here we have the okay, so this I've already explained it. The Boolean, if it's north, the current position, and I explain here that if above 33.92, then it goes on the other side. Okay, so and I put an explanation. You can read it. I will publish the code on the YouTube channel, and this is the mathematical triangulation of the moon, the way it moves around at 360 degrees. It's a trigonometric actually. Okay, so I'm not going to explain the mathematics, just work with it. Okay, so and here you have the display of your screen, you know, LCD print, LCD if set the cursor 0, you should know what the cursor is. 0, it's the first row of 16 blocks, and the second row it's 1, 0, 1, it's the other 16 blocks. It's got 32 blocks, and 16 on the first line, as you see here. Let me show you. This first line, okay, it's 0, 0, and this is 0, 1. That means that you put the cursor here to type. You know, if it's north, it's north, it will type there. If it's south, it will type still there. All right, I mean, I'm not going to explain the. It's the project itself. I like to interesting. Okay, so and here it's a void loop, and it goes through all the process, the current phase, the current inclination, the last update for the PW as well to change its if it's lighter or dimmer. Okay, so here's waxing and winding, and you know, waxing is light is coming in, and winding is light is going out. So as the Earth's shadow move across the moon, which is illuminated by the sun, you can see that the shadow will disappear completely. You have a full moon, and then the waxing comes back, so the winding comes back, and it takes the moon light slowly away. All right. This is a very good project for school, guys. I mean, I'm not joking. I mean, if I present a teacher with something like this, they should be quite amazed. And also, you learn about how the shadow of the Earth covers the moon's surface, illuminated by the sun light. So it's a very interesting project. Okay, guys, I think I covered everything. Remember that you need the NTPClient. Also, you're taking, this is for the, should put here the use UTC time. Okay, so in my case it's 7,200 seconds. And this is 60,000 milliseconds. Okay, so this will give me a +2 from the actual time. If I take this one off and put 0 here, then I will have I will be 2 hours behind. Okay, so adjust my latitude from the Greenwich Mean Time. All right, I think I've covered everything. Let's go back to see here. And oh, there is another thing. So, I also put, let me just check. Okay, so it's got the timing, phase, 29. Let me clean up this one. So what is display on the LCD is display on the serial monitor as well. Okay, so you will have on the serial monitor like this. In this case, it's 940 by time, phase 29.2, widening, and December declination 5 degree. PW it's 107, but this changes as the moon become less illuminated, more illuminated. All right, so going back here, okay, I haven't seen the green light in the last 3 days that I've been running this testing this project, so I don't know when the green light is going to come up, and I'm waiting for when it's going to dim more, and then this is going to lit up. So now declination now is gone to 5.9. The PW is still the same, 107. The time and the phase is 29.2. Okay, guys, I think I covered everything. Yeah, I don't see anything else that, yeah. Okay, I hope you like. If you like it, please give me a thumbs up and have a good day. Thank you. Bye.